All right, Unit 0, Lesson 3. We are talking about inequalities with absolute values. The thinking is just a little bit different than absolute values inequalities that we just did. So we went from having an equal or an equation, and we're thinking of substituting x with something that equals something to something that is less than something or greater than something, okay? So you still isolate the absolute value on one side of the equality just like you would for an equation, but then what you're left with is either some sort of inequality symbol, and if it involves a less than symbol, then you want to convert it to a three-part inequality. Okay, so it's a little trickier when you're trying to figure out a number that's less than something in an absolute value or greater than. So for something simple here, the first one says the absolute value of x is less than 2. So you're left with the absolute value alone on one side and a less than symbol. Okay, it said convert it to a three-part. What you're going to do is take whatever's in the absolute value bars and put that without them. And then on this side, you're going to add another less than symbol and then put a negative of whatever was on this side. That's how you turn it into a three-parter. Okay? So that's where that comes from. Now, when you go to read this and I want to try to graph it, I see that this is on the end, right? But this little part right here, I turn back around. This is x is greater than a negative 2. So if I'm graphing it, it's greater than a negative 2, but not a negative 2, right? Because it's got to be less than. And then, right here. So the other one is a positive 2, and it's not a 2 exactly. It'd be less than a 2. So all of these numbers would work in this equation. The absolute value of a negative 1 is 1. A 1 is still less than 2. Okay, so that's how you get those. So let's try this one. We want to isolate our absolute value on one side. All right, get rid of that here. To isolate our absolute value on one side. Negative divided, we just divided by a negative. So don't forget to flip. That still matters, okay? So 4x plus 1 is less than, this is a positive 3. Okay? Whatever's in here, less than 3. So you take whatever's in here and put that back without the bars, and then put another less than symbol and put minus whatever's on the other side. Okay? Because these are all the different things, kind of like this one. These are all the different numbers, whatever this is in here. That would make this a true statement. So if I solve these like you would before in the last lesson. So negative 1, and I didn't divide by negative, so I'm not flipping anything. I would flip both of them if I needed to. Okay. And if I'm graphing that is x is greater than a negative 1 and x is less than a half. So negative 1 is here, a half, a positive 1/2 is right there. And if it's greater than a negative 1 but less than a half, you're like that. So negative 1.5. These are items that you can put in for x, and you end up with an absolute value of between a negative 3 and a 3, which would make this true. Okay, so even though, notice we started with a greater than symbol, we ended up flipping it because we divided by a negative number, which left us with a less than symbol. So if you have a less than symbol on one side, if you're left with the less than symbol, then you're turning it into a three-part inequality. Okay, so it doesn't really matter what it starts with. This one I flipped it and turned it into a less than problem. Okay, so this one here, let's see what happens when we do this one. I'm isolating my absolute value on one side, putting them back in there. And now this one's less than a -2. An absolute value is less than -2. That doesn't sound right. Since this whole side has to be positive, then there's nothing that would make it less than a -2. So this would be your no solution one. This is what this means up here by these little asterisk symbol. It says, if the less than symbol is followed by a negative number, then there is no solution to the inequality, because the absolute value cannot be less than a negative number. Okay? All right. Next page. All right. What if you have a greater than? That should be your next thought. Instead of turning into a three-parter, those three-parters are ands. When you have a greater than, you're going to be turning it into an or. Okay? You're going to remove the absolute value, keep the rest of the problem the same on one side, add the word or, and write another inequality the same as the first, except flipping the symbol and changing the sign. So that seemed like a lot. So look, here's the easy one to start with. I have an absolute value alone on one side, and I have a greater symbol left, and a positive number 2. All right? So what I need to do, instead of turning it to an and, I put it the same thing back without changing anything, add the word or, and then flip the symbol and add a negative to the 2. Okay? I know that's a lot. If you have an absolute value, if you need to, write them side by side on a flashcard. If you have an absolute value, you are putting the same thing down without the absolute value bars, adding the word or, flipping the symbol, and adding a negative to the number. If you have a less than 2, then you are keeping the x in the middle with a less than 2 and adding a -2 over here. So that's kind of a good flashcard item, okay? So the graphs are going to look different when it's an or, right? So where is a -2 is down here, and a 2 is up here, and it's going to be greater than a 2 and less than a -2. Let me get my key out, make sure I'm not messing anything up. And then because it's an or, you're going to have -infinity, -2, soft bracket, union, soft bracket 2, positive. Okay? So that goes with that one. And this one had what? It was a soft bracket, -2, 2. So maybe you can add that to the card. All right, so we have an absolute value alone on one side and a greater than symbol. So we write down what's in the absolute value, keep it the same way it is. Then you write the word or. Then you write it again, you flip the symbol and add a negative. And then in this case, you just needed to solve. Do a little more, okay? And yes, you can get some fractions here. I didn't divide by negative, so I didn't change anything. Oops. Don't forget we put an or in there. And then this one, I should have wrote higher up. This is going to be 4x is less than, -1 divided by 4 is going to give you x is less than, I didn't divide by negative, so I didn't flip anything, 1/4. All right, let's think about what these things are. This is over here somewhere. And then 4 into 11 goes what? 2 times and a couple of extra. So this is up here somewhere, 11 over 4. And it's greater than this one. Or less than this one. And it's an or, so we want to keep both of them. Soft bracket, soft bracket. Okay, these are ors now. All right, here's one here. Add 4. To isolate my absolute value on one side, I'm going to get the, and I divided by, sorry. Absolute value. And this is 4, right? Positive 4. So this is going to be okay. And then let's see, negative 4, 1, 2, 3, 4 is down here. 1, 2, 3, 4 is up here. And it's going to be greater than or equal to 4, less than, oops, soft bracket, that way, and negative 4, okay, and then the last one, absolute value, and I divided by a negative. So I divided by a negative, so I flipped it, got a negative. Okay, absolute value greater than or equal to a negative. Absolute value, this is positive, greater than or equal to a negative 2. All positive numbers are greater than a negative 2. All numbers are greater than a negative 2. So all the numbers are more. Okay? And we'll do the practice on another video.